Hello everybody and welcome back to Maths Miss Buick. We're still focusing on differential calculus here, and in this video we're looking at the second derivative. So before we begin looking at some examples of how to calculate second derivatives, we must first understand what is the difference between dy dx and d squared y over dx squared. Well, dy dx is the first derivative, and of course the first derivative will always give you a slope of a tangent. So represents the slope of the tangent to the curve at any point on the curve. So just remember, dy dx gives you the slope. Whereas d squared y over dx squared gives you the rate at which the slope is changing over a given interval. So to repeat that, dy dx gives you a slope, and then the d squared y over dx squared gives you the rate at which the slope is changing over a given interval. So let's look here at two examples of finding d squared y over dx squared. So here we go. So let's begin first of all with example A. So here we have our function y is equal to 3x plus 1 over x plus 4. So we're going to begin our question here by remembering that 1 over x can be brought into x power negative 1. So let's do that first. So we bring up the x, and when we do that we have to put on a negative power, and it's a negative 1 plus 4. So in this stage here we have not differentiated anything, we've just simply changed our 1 over x into x to the negative 1. So now let's begin by finding the first derivative. So it's important to know as well, you cannot find the second derivative unless you have the first derivative first. So let's differentiate 3x, well that gives us 3. We bring our negative 1 down in front, so it's now negative x. And we reduce our power by 1, so negative 1. And of course, constants go to 0. So here is our dy dx. Next of all, we're working on the second derivative. So that's the actual question. And we represent by that notation here. Well, let's differentiate 3. Well, we know constants go to 0, so that's gone. And we can bring our negative 2 in front to our negative 1. And multiply, and of course negative by negative is positive, and it's a 2. There is our x, and we reduce our power by another negative 1, so now we have negative 3. And if we want to tidy it up, well, we can leave the 2 on the top, and because we have an x with a negative power on it, all of it goes under the line, and you change the negative power to a positive power. So that there is the answer to the first part of the question. Now let's look at the second example. So let's begin by remembering that anything with a root on it like this is represented with a power of a half. Now it's important to note I have not differentiated here, I've simply just changed notation. So let's get the first derivative, so that's represented by dy dx. So we bring our power down in front, so we get a half. There is our x. We reduce our power by negative 1, so it's now negative a half. So there's our dy dx found. So let's find our second derivative. So that's represented by d squared y over dx squared. So let's bring our negative a half down in front. And of course, negative a half by positive a half is negative 1/4. So be careful with that. There's our x. And reduce our power down by negative 1. So now we're down at negative 3 over 2. So we have the actual differentiation of the second derivative done, but let's give this a little bit of a tidy up. So first of all, what we're going to do is we're going to keep our negative 1 on the top because that's our numerator. Our denominator will always be on the bottom anyway because that's what it is, it's a fraction. So there's our 4. And we can see here that this x has a negative 3 over 2 on it. So let's put the whole lot of that under the line. Now I have a video explaining this in more detail, how to tidy up powers like these. So next of all, what I'm going to do is I'm going to leave my negative 1 over 4 there. And let's change this into 1/2 multiplied by 3. We can see here that 3 over 2 is the exact same thing as 1/2 multiplied by 3. And another board. So I'll move this one up here. So now let's finish off the question. So we have it's a negative 1 over 4. Well, we know that this x power of a half is represented by a square root of x. But don't forget as well that the 3 is inside with our x. So there we have our answer to part B.